Well, hello. This is Gmodism here, and I had some interesting thoughts a few months ago, and I'm ready to share them with you because, I just wanted to, tell people about this idea and see what people think about it. It would be really interesting if one could get some professional feedback. Of course, I'm aware of the very high probability that I might be wrong and there might be proof against this, or maybe not. Maybe it is something that others already know, or maybe it's even a new theory, I don't know. But I anyways wanted to share this with people because I think it's a really interesting idea, and it's a bit an interesting title, so I'll just read it straight from the paper here. So this video is about how total entropy leads to the rebirth of the universe because the distance between particles are relative. So I will do my best to try to explain this in a way that everyone can understand in the shortest time possible. So first we're going to talk about particles. It can be hard to measure the size or distance between two particles. That is because to measure something you need to input energy. And if you input energy, you will also disturb or affect the measurement. So the more exact you try to be by using more energy, the more you will influence the result, which is a hard problem in physics and why you can't measure stuff very accurately, basically. There is a limit to how accurate you can measure something, and that's the reason. So, we have a particle. How big is it? Well, you can also explain a particle as a wave. That means the particle has an absolute, undefinable small center, and from that center it goes out like a wave. Think a light that's glowing, like this, like this. I don't know. Yeah. So if you want to go to the center of the light source, you go closer and closer, and it's more light through the center. But where does it begin? It can be hard to tell because the radiation is like an aura around. The same with like electrons. The electrons are like clouds around their cores, their neutrons and protons. They're like a cloud around, and it's hard to say where the electron is physically because it's kind of all around. So if you have an isolated electron, it will influence everything around it. So it's kind of, it's like a wavelength, basically. Particles and wavelength can be explained by the same way. And that makes it hard to wonder where a particle starts and where it ends. It's not like having something clear like this, really, because it's kind of fuzzy all around. So that's how I first explained particles. Of course, particles are not all the same, and some are different from other ones, but generally speaking. Okay, so if you have an infinite vacuum, we have an infinite vacuum here, alright? And we have two particles. Right. What's the distance between these particles? Well, where do they end or where do they begin? And then we come to the conclusion that, well, it's kind of hard to say where they end and where they begin. It's not like these balls, they're kind of fuzzy. So where should we measure from? Well, the center. Okay, well that's fine. The center, to know the center, we need to be able to know the entire field all around, and it has to be symmetrical, but say it's symmetrical, and we can find the center, so we can make a measurement. Then's the question. Relative to what? we can't have, you know, when we are measuring this small, we can't come with a measuring stick, because the measuring stick, it will first not be accurate enough, and second, it will change size dependent on the temperature. Like, oops, the room is 0.1 degrees hotter than a second before because I breathe on it, and suddenly it's longer, which makes a huge difference on a very small scale. Yeah, and then we have the other problem. If we have this measuring stick, how are we going to measure the particles without influencing them? Might the presence of the measuring equipment actually increase or decrease the size of the particles? Maybe, and that will affect the measurement. So in that case, we can come to the conclusion that if we have two particles in infinite space and we don't have anything relative to measure towards, then it will be the kind of strength of the field of the particles that we use to understand what the center of them are. And if that field changes, it will also change the distance of the measurement, because we don't have anything relative to measure it against. This means that we can't measure the size, the length, we can't measure the distance between two particles in infinite vacuum. So yeah, that's a problem. And then we can go to the next point, because according to this little theory, the particle distance, the distance between two particles, is, frankly speaking, relative. It's completely relative. So, yeah. And if it's relative, we have to use other structures in space, like where the sun and the planets are in this galaxy and that galaxy, to get a framework to kind of measure the particles, yeah? How far the particles are from each other if we have this framework. But the universe is going towards entropy, like galaxies, stars, planets. Galaxies are, you know, it's expanding. From what we can observe, the universe is expanding, and it's leading to more entropy all the time. This means that if we reach total entropy, that means if all particles in the entire universe has the same distance to each other. So if we have three particles here, and they all have the exact same distance. I don't have three hands then. Want some of those Shiva hands would be useful. We have all particles in the universe has the exact same distance to each other. Then we come to the interesting part. There is no relative framework to measure all these particles against anymore, because they're all spread out infinitely, you know, it's total entropy. Particles have reached total entropy. There is exactly the same degree in the entire universe, and all the particles are at the exact same position towards each other, or distance towards each other, yeah? And it also means that all our particles somehow, I guess, maybe it's necessary, maybe not, need to be kind of degenerated or reverted to the lowest possible energy state, or at least reach the same type of stable particle. Yeah. So if this is the case, we don't have a framework to measure the distance between the particles. So in that case, because the distance is relative, we can say it's infinitely small or infinitely large. Say it's infinitely small. Yeah, well, if we have a total entropy and infinitely small amount of, you know, distance between these, then it means we have a Big Bang. So, according to this theory distances between particles being relative, it would lead to the conclusion that total entropy in the universe means Big Bang, because there is no relative framework to measure distance. So it might as well be infinitely large distance between the particles or infinitely small. Because really, does particle end anywhere? I mean, gravity, the gravity on Jupiter is affecting me here. I can't measure it with, daily tools, but we feel it. Jupiter keeps the asteroids of Earth, basically. It's our shield, kind of. Very nice, Jupiter. Like that guy a lot. Don't like getting bombarded by asteroids, so that's cool. Skipping them. But anyways, gravity doesn't seem to have a real endpoint. It seems to just have exponential scale of scaling off and being less prominent. So if you think like that, maybe all particles are like that. And then I come to, I think, the last conclusion here about this is that maybe the explanation for how all this works is that the amount of entropy in the universe is deciding, affecting, and basically ruling the natural laws in the universe. And this is also why it's so hard to have a unified theory, that you can measure everything using the same system, which you can't. If you measure small particles with our daily Newtonian physics, it doesn't work very well. And if you try to measure our daily life with particle physics and theory of relativity, it doesn't work very well either. And maybe that's because of of entropy on different scales. So my theory is here that the grade of entropy within a system or a universe or the total creation is basically affecting the natural laws. Yeah, I hope I got myself reasonably well understood. I'm just going to checking my paper and see if something missed here. No, I think I got it. Yeah, exactly. Yeah, because all of what I said, this might be the case. This might be how the world works, how the natural laws are getting affected by entropy. But of course, this is just a theory, and if you know, in a scientific manner, if you know a way to disprove this theory, please do it. Or if you know physics researcher or someone that has actually studied a lot of this professionally and knows a lot more than me, please send this to them and maybe we can reach an answer. Anyways, I thought it was kind of cool to get this little random idea, and thank you very much for watching this video and letting me share it to you, and I hope this will be beneficial for you or anyone to understand the world better. Yeah, this has been Gmodism. Check the links below and I'll see you in future videos. Bye bye.